All right, so you're going to open up your notebooks to your green divider. This is our third topic. We're going to do this more as a guided practice, but I'm posting this video in case you miss it. But we're going to title this, topic 3, we're going to title it Flipping the Sign. So flipping the sign, this is topic 3 in your green divider tab in your notebook. Then you're going to flip your notebook to the next page. So you just filled out solving one step inequalities. And you're going to flip to the back of that. You're going to glue this page in. Like I said, it's guided practice. We're going to go through it together. It's more of a discovery. So you're going to take your glue stick, glue this in the back, glue this on the back side. And we're going to determine when you need to flip the sign, or really it's the inequality symbol. So we'll discover that, and then that'll hopefully help you remember when to flip it around. So flipping the sign, or the inequality symbol. All right, so most of the time, and you'll see as we did our one-step inequalities yesterday, you basically just carry down the inequality symbol as you solve the problem, okay? So with the examples we did yesterday, you can see how we literally just carry down the greater than or equal to sign. We carry down the less than sign, and so on. But sometimes you don't just carry it down, and that's what we're going to figure out today, is when you don't just carry it down. So instead of just giving you the rule, we're going to figure out the rule together. So I have a starting point here. I have two numbers I'm comparing. So my starting number is 2 and 4. I want to write the inequality symbol in between those numbers that would make sense. So 2 is what compared to 4? It's 2 less than 4, 2 greater than 4. All right, so 2 is less than 4. Okay. Now, as we go down here, we're just going to perform this operation on the number above it. So it says add 2. So I'm going to add 2 to the number above it. So 2 plus 2, that would give me 4. If I add 2 to 4, that would give me 6. And then I'm going to figure out, what inequality symbol do I have? Do I still have a less than sign, or do I need to turn it around and make it greater than? Well, 4 is less than 6 in the same way that 2 was less than 4. So if I add 2 to each number, my inequality symbol would stay the same. What about subtracting? So I'm going to subtract 3. I'm going to subtract 3 from both numbers. So 4 minus 3 would give me 1. 6 minus 3 would give me 3. So I need to figure out which inequality symbol would go in the middle here. 1 is what compared to 3? Well, it's still less than 3, so I still have a less than sign. All right, now I'm going to add negative 2. Okay, so again, that's kind of the same as subtracting 2. But if I add negative 2 to 1, that would give me a negative 1. And you can use your calculator for any of this if you need. 3 plus a negative 2, again, that's kind of like subtracting 2, would be 1. So I'm comparing negative 1 to positive 1. Negative 1 is what compared to positive 1? It's less than, right? Negative number is going to be less than a positive number. All right, I'm going to take this number and I'm going to subtract negative 4. So adding negative 2, that was just like subtracting 2. Subtracting negative 4, that's really kind of like adding 4, right? Subtracting a negative is the same as adding. This is just to kind of help me out a little bit. Okay, so if I have negative 1 and I add 4 to it, or subtract negative 4, that would be a positive 3. And I'm going to add, or excuse me, I'm going to either add 4 or subtract negative 4, whichever way you want to think of it, to the 1, and that would be 5. So I'm comparing 3 to 5. 3 is what compared to 5? Well, it's still less than, right? 3 is less than 5. All right, now I'm going to multiply by 2. So 3 times 2 that would give me 6. 5 times 2, that would give me 10. I want to see, do I have the same inequality symbol? 6 is what compared to 10? Less than. So far, when I've done different operations to the numbers involved here, my inequality symbol has stayed the same. Let's see what happens if I subtract 7. So 6 minus 7, that would be negative 1. 10 minus 7, that would be 3. So negative 1 is what compared to 3? Still less than, right? So negative number is less than a positive number. Now I'm going to multiply by negative 3. So negative 1 times negative 3, you can use your integer operations here to help you, or you can use your calculator. Since we're dealing with multiplying by negative, maybe your calculator might be more of use for you here. So I'm going to type in negative 1 times negative 3. Well, that would give me a positive 3, which would make sense, right? A negative number times a negative number gives me a positive answer. So this would be a positive 3. And the other number I was working with was 3. So I'm going to clear this out and do 3 times negative 3, which would give me negative 9. So let me get rid of the calculator for a second so I can see everything. So I'm comparing 3 to negative 9. Well, this is a positive 3. This is a negative 9. 3 is what compared to negative 9? Well, 3 is greater than negative 9. I'm going to take my highlighter and make note of this here. I just switched my inequality symbol around. And I switched it when I multiplied by negative 3. Okay? We're going to see if we add and divide and subtract and multiply from here, what happens to my inequality symbol now? Is it going to stay greater than, or is it going to switch back? So I'm going to add 5 to each of these numbers. So 3 plus 5, well, that would give me 8. Negative 9 plus 5, so remember this is a negative number. I'm adding a positive number so it becomes less negative. So it would be negative 4. So 8 compared to negative 4, so 8 is greater than, right? Because you have a positive number is always greater than a negative number. All right, I'm going to take these numbers, I'm going to divide by negative 4. So 8 divided by negative 4, so 8 divided by 4 would be 2, right? But if I divide a positive by a negative, that would be negative 2. Negative 4 divided by negative 4. Well, that would be 1, right? It's a number divided by itself. So I'm comparing negative 2 to positive 1. So negative 2 is what compared to positive 1? Well, it's less than it. Okay, so notice my inequality symbol switched back around. It went from a greater than sign to a less than sign, and that was when I divided by negative 4. Okay, we're trying to see if we can find like a pattern or a rule here about when this symbol or inequality sign is going to switch back and forth. All right, I'm going to subtract 2 from both numbers. So negative 2 minus 2, that would be negative 4, right? It's like 2 steps to the left on the number line. 1 minus 2 would be negative 1. So negative 4, I'm comparing to negative 1. Negative 4 is less than negative 1. And I'm going to multiply by negative 1. So negative 4 times negative 1. Well, if it was just 4 times 1, it would be 4. Then I have to figure out if my answer is positive or negative. So a negative times a negative is a positive. So negative 4 times negative 1 is a positive 4. And if you're a little stuck on all these negatives here, if you're a little stuck on all those negatives, you can pull up your Desmos calculator to help you. So just to show this in the calculator, if I have negative 4 and I multiply it by negative 1, I do get a positive 4. All right, and then our other value was negative 1 times a negative 1. So again, a negative times a negative would be positive. So if I clear this out, negative 1 times negative 1 gives me a positive 1. So I'm comparing 4 to a positive 1. 4 is what compared to 1? 4 is greater than 1. So my inequality symbol switched back around. And it switched back around when I multiplied by negative 1. So the key here, looking at these follow-up questions, that's going to help us figure out our little rule about when we're going to flip the sign or the inequality symbol. So when did the sign change? Well, the sign changed when we multiplied by -3, when we divided by -4, and when we multiplied by -1. So we're going to try and come up with a conclusion about when will the sign change, or the symbol, inequality sign or symbol. They involved negative numbers, but only with a couple different operations. I subtracted a negative number here and it didn't change the sign. I added a negative number and it didn't change the sign. So the negative number is important, but only with 2 of the operations. So we can conclude that you switch the sign or change the sign. I'll say flip the sign when you multiply or divide by a negative number. So that's what we can conclude. So basically, the times you would end up multiplying or dividing by a negative number is if you start with a negative coefficient, or because that would require you to divide by a negative number if you had a negative coefficient in front of your variable, or if you had a negative denominator, because that would require you to multiply by a negative number. So if you had a negative coefficient or a negative denominator to start with, that would require you to multiply or divide by a negative number when you go through the process of solving the inequality. So you may see that in some of the questions that you have to solve today in class.